Hey guys, what's up? This is your civil bro Mainak, and today we're going to discuss about bending moment and shear force. So I had made a video, previously on this bending moment and shear force, and I'm going to make the second part of it. If you haven't watched the first part, you can just go and watch that, or you can just watch it now because I'm going to cover all the basics again, the sign conventions. What is the best possible sign convention for the shear force and the bending moment as per me, the easiest one, and then I'm going to just go into some numericals. Basically, we're going to cover the the for the competitive exam, as well as if anyone is in their semesters preparing for the subject and they haven't they want a different perspective from their professors. So I'll just try to make it as simple as possible. Firstly, we are going to go with this say fixed beams, then simply supported beams, and then overhanging beams. So and the loading will be your point load and UDL. So there are other loads also, which if you want to just go in little bit advanced level, there is UVL, there is a option of inclined load as well, but I'm not going to cover this, because if you are interested, then you can just comment below, then I'll just try to cover that all as well. But in most of the competitive exam, I'm talking most of the competitive exam, these loads are important, like all the state JE exams. These loads and these portion, they ask more questions, and if you know the basics, then I think you can solve those as well. So I'm going to cover this, and stay tuned. The video maybe it will be a little bit longer, but if you are interested to know the subject, consider hitting consider watching the entire video. And there are other videos on my channel as well, on various software and their applications, so you can check that out and subscribe this channel. So let's get started for today's video. So today we'll start bending moment and shear force diagram. So first of all, we'll know a little bit about the shear force and bending moment, and then we'll solve some numericals. So whenever force acts on a body, external force, some internal reactions develop. Shear force and bending moment are part of that. So if we consider a simple beam subjected to some load, maybe a simply supported beam subjected to a point load like this. To resist this particular load, some forces develop inside that particular beam. So those forces are known as shear forces. So we'll know a little bit more into the technical detail later. First of all, what we'll do, we will solve some numericals, and then we will get back to the concepts. So before solving the numericals also, we'll need these sign conventions. So I'll give you a pretty simple sign convention which you can use. There may be some differences in other books, different books, but to my experience this is the easiest. So I'm going to tell you this, and if you follow this, you'll easily be able to solve any numericals. So for the shear force, if you're going from left to right, upwards is force is positive and downward force is negative. Okay, so this is positive, that is if you're going from left to right, this is positive. Now upward force is positive, and if you're going from right to left, the downward force is positive. Okay, and similarly you can just tell what is the negative here. Anything the opposite is negative. So if you're going from left to right, the downward force is negative, and if you're going from right to left, the upward force is negative. So it is like this, pretty simple, isn't it? So when we solve the numericals, it will be more simpler to you. Okay, this is about the shear force. Now what about the bending moment? Now bending moment, you can just easily explain it. So when you're going from left to right of a beam, then your clockwise is positive, and when you are going from right to left of a particular beam, L to R means left to right. Okay, when you're going from right to left, that is R to L, then anti-clockwise is positive. So I'll just write this, anti-clockwise is positive. Now let's move further. Sometimes this anti-clockwise and clockwise is also called hogging. Hogging and is negative and sagging is positive. So this is sagging and this is hogging. So you can also remember this also, but in my experience the clockwise and anti-clockwise are easier to comprehend. Later you can understand the hogging and sagging also. These both of the things are the same. So let's just solve a numerical. So this is a cantilever. This is a simply supported beam. And the next type of beam, this is an overhanging beam. You see there are two simply supports and portions A and A are this cantilever or overhanging portions, and the portion L is another simply supported. So these are the main three types of beams which you will find numericals in your competitive exams as well as your curriculum. So let's try solving one of them. By solving, you can solve with me, and if you need more time, you can pause the video and do it. And if you have any doubts, I repeat, any doubts, by the end of this video you can comment, and I'll make sure I make a video to solve your particular doubt. So we have a cantilever beam here, and it is subject to a load W and length L. First of all, draw the section, and since it's the cantilever beam, we don't need to find the reactions, and since it is a cantilever beam, we will move from right to left. So we know if we're moving from right to left, downward forces are positive, and there is no forces which are acting from bottom to top anyway, so this will be positive. Okay, so I had drawn the W in the wrong side. W will be up, so this is positive. I'll just erase this W and give a W here. So W is positive and there is no other force, so the shear force won't change. Now it's time for the bending moment. Now bending moment, this, if you just consider the left end as fixed and this is L, then it is rotating clockwise. The left end, if it kept fixed, is rotating clockwise. But as we know, if we are moving from R to L, that is right to left, anti-clockwise is positive. So this W is your negative. So if W is negative, the bending moment at the left end will be W into L, and the bending moment at the extreme right end will be W into 0, that is equals to 0. So now I'm just showing you that if you just keep this end marked under as fixed, then it is moving anti-clockwise. Now if we take a section X from the right end, then we'll see that the bending moment is W into X, or rather minus W into X. Similarly, if you replace X by L, then it is W into L. So you can do by this method as well, using sections. It will be pretty handy, especially in the time when you solve overhanging beams. So this distance is your X, and this bending moment is Wx, and at the extreme, the maximum bending moment is your W into L. So the next question, let's see, we'll take the same beam. This time we'll take a load, UDL load, W per meter, and the length will be L, and simply we'll solve the shear force and bending moment of this particular beam, or rather I should say cantilever beam. Write SFD and BMD, that's pretty handy. Now SFD will draw here, and we are going from right to left, so downward force is positive, right? So the shear force which will be acting here, total shear force or the maximum shear force, is W into L, and W into L will be then at the extreme left corner. Okay, so it will start from 0. Let's say if you draw a section, that will W into X, and maximum will be W into L, similar to the point load numerical of bending moment we have done, isn't it? So the shear force will be W into L, and at the maximum point, and at X it will be W into X. So let's draw the diagram. I'll give you a moment to understand the concept and do it yourself. Okay, let's draw it. So For the shear force, the UTL will give a linear in a way, W into L positive. But as you know, for the bending moment, the force has to be multiplied with the distance. Let it be A and let it be B. It is moving in the clockwise direction, which is negative. Since we know from right to left, anti-clockwise is positive. If A is fixed, it is moving along the clockwise direction, so it is negative. Now, the moment will be W into L, that is the load which is fixed, and it will multiply it by the distance, the bending moment at A, minus W into L into your L by 2, that is the distance by 2, which will be minus W L square by 2. So the bending moment at A will be minus W L square by 2. Similarly, if you take a section X from B, it will be minus W X square by 2. So I'll give you a moment to understand the concept and then we'll draw the diagram. But here you should know that it will not be a straight line. See the equation, it is WL square by 2 or WX square by 2, means it is parabolic. So we'll draw a parabolic line and move towards the next question. So the next question we will see and will solve a simply supported type. So the simply supported questions are a little bit different. The main difference is that you have to find out the reactions whenever you see a simply supported beam. Let it be A and let it be B. A point load of W is acting on this particular simply supported beam in the span AB. The total length of AB is L and it is divided into two parts, A and B. First of all, let's just find out the reaction. So for finding out the reaction, we have some weapons. Those weapons are, for shear force, summation of moment at A equals to 0 and summation of moment at B is equals to 0, since they are simply supported, which you can't do in place of fixed. And also summation of forces at A equals to 0, which gives us RA plus RB equals to W. And if you do find out moment at any point, whether it be at A and B, we can find out the forces. Summation forces MA is equals to 0. Now, what does it imply? RB into L is equals to W into B. It is very easy that if RB, if you take as positive, then W will be negative, since these are acting along the opposite directions in respect to A. So RB into L is equals to W into B. We will find out the movement, which gives us RB equals to WB by L. And once you find RB, if you just put it in the first equation, RA plus RB equals to W, we'll find the value of RA as well. And we know what the value of RA will be, right? The value of RA will be your W minus WB by L, which will in turn give us WA by L. So I'll give you a moment to understand the mathematics part. So the maths is pretty easy. So you get here the two reactions, RA equals to your WA by L and RB equals to WB by L. So the reactions you can write in your numerical answer part. So just remember, whenever you have any simply supported beam, finding or an overhanging beam also, finding out the reactions is the first thing which you need to do. You cannot do anything without finding out the reactions. Now let's go for the SFT and BMD, shall we? Now mainly we need to find SFT at 3 points and also the BMD at 3 points. So we know what is RB and RV, right? We will start from the left this time. From the left, upward forces are positive, so RA will be positive, that is WA by L. So you can mark the WA by L here. I'll just explain it to you and give it a moment to understand. WA by L here, you can extend it since there is no force up to this point. This point we are having a force, so what will be it? Just calculate it. it will be WA by L minus W. Why minus? Because we're going from left to right. Remember, from left to right, downwards is negative. WA by L minus W. We know what it will give, right? If you do the maths, it will give us WB by L. I'm taking WA minus WL by L, and we'll take W common, and it will be A minus L by L. So A minus L gives us B, right? So it will be WB by L, and then it will give us WB by L, right? And then we'll join it will be negative. Now let's go for the bending moment. For the bending moment part, what we need to do is we need to find out the bending moment from the left side. Let's go from the left side. Left side clockwise is positive, so in respect to B, the downward forces, that is RA, is moving it in the clockwise direction, as you can see it. So this will be WAB by L. So WA by L into your B, which is WAB by L. Since it is positive, it will be it will be plus WAB by L. And now we have this W load here. Now W is rotating the point B in the anti-clockwise direction, so it will be negative. So bending moment at B, let's find out, it will be WA by L into L minus W into A, right? Minus W into A. So we'll just simply write it. Load into distance is the formula for the bending moment. You need to know the basics, as we have already discussed. So what will it actually leave us? If we do the math, it will leave us 2 L cancel, WA minus WA equals to 0. Exactly what you need. You can validate your numerical by that. If you are having a simply supported beam, the moment will be 0 always, as we had done earlier also. Summation moment of A equals to 0, and we could also do summation moment of B equals to 0, because whenever we are having simply supported, the moment is always 0. So this is the basic concept, and if you understand these basic concepts, it becomes very easy to solve numericals also. You need to get your concepts clear. So moving towards yet another numerical to clear your queries. So let's get through this quickly. We'll have a fixed beam, or rather a fixed cantilever beam, and we'll have a point load of 400, and then we'll have a 300 point load, and then we'll have another load of your 800, and then we'll extend it and we'll have another load of 500. So these are the loads which are acting. And remember, since this is a fixed cantilever beam, first of all we don't need to find out the reaction, and second of all there will be moment along end A or the fixed end, so there will be a bending moment. Unlike where we have simply supported, the bending moment is always 0 in simply support. You need to understand the concepts, that's why I am repeating this again and again, besides solving just a numerical. The total length is your 2 meters for this particular beam. Now let's find out the shear force. Obviously we need to go from your right to left. Downward forces are positive here. So now this is 500, and after this we need to add here 500 plus 800, which becomes equals to 1300, right? Now at next point 1300 plus 300 will be there at point C, which equals to 1600, right? So we'll just write 1600 here. Like this, you need to know that all the forces will add up, that is 1600 from here,
and then it will be your 2000, and then it will be, this 2000 will be last one. So this will add up everything. So similarly in the bending moment also, the same thing will be there. 500 at D it will be 500 to zero point 0.5. At C it will be 500 into 1 plus 800 into zero point 0.5. At E or B it will be 500 into 1.5, and then it will be 800 into your 1, and then it will be 300 into zero point 0.5, like this. And since at B, if we are going from right to left, so anti-clockwise is positive. With respect to your A, all the forces are moving your clockwise direction, so everything will be negative. So like this we are finding out the bending moment and shear force. I have calculated this, and you can pause the video and solve it first and then match all the answers. So the answers are pretty simple. The next thing which we are going to discuss, this is the last question which we are going to discuss today. It is about a simply supported beam. Sorry, it is not a simply supported beam, it is a fixed cantilever beam, and it is subjected to a point load as well as a UDL. So we need to know what happens here. So first of all, this is a solved question, and first of all you can just take the screenshot and try and attempt it yourself, and after that if it doesn't come out, then you can watch the solution to this. So suppose we have this particular question which is given. We don't need to find out the reactions, as this is a particular fixed cantilever beam. So first of all, the load which will act, shear force which will act here is we're going from right to left, so all the downward forces are positive. So 2.5 is positive force. We'll write 2.5 from D to E, 2.5 force, and from D to C, a load of 1 kilonewton per meter is being you know going on. So at particular C, we'll add 2.5 plus 2 into 1, which equals to 4.5. So now since this is UDL, it will go like a sloped line from here, from D to C portion, only for the D to C portion. So it's at C it is 4.5, and from C to E or B there is no load, so it will remain as 4.5. At B, another load of 3 will add on, acting in the downward direction, that is positive, it will be 7.5, and up to A it will stay as 7.5. So this is the shear force diagram for this. And for the bending moment diagram, we'll find out step by step for this. Okay, so bending moment diagram, we are going from right to left here. So right to left means your anti-clockwise is positive. So anti-clockwise is positive. Now you can see all the loads, if you're keeping A as fixed, and all the loads are acting in the clockwise direction, so everything will be negative, so no need to take care of the sign. So at E, the bending moment will obviously be 0. We are starting from E, there is no distance, it will be 0. At D, the bending moment will be 2.5, that is minus 2.5 into 0.5, which is what I have written here, minus 2.5 into 0.5, which gives you 1.25 kilonewton. Now at C, it is the next point, it will be interesting. The shear force will be minus 2.5 into 2 plus 0.5, that is 2.5, and minus 1 into 2. So minus 1 into 2 will be the load, and the distance from C. What is the distance from C? Since you are finding out the bending moment at C, the distance from C will be 2 by 2, that is 1. Okay, so that's what we have written here, minus 2.5 into 2.5 minus 1 into 2 by 2, which gives you 8.25. So now when you draw the diagram, only for the particular UDL portion, what you do, this you do make as parabolic. Why this you make as parabolic? Because there is a UDL there. So for the UDL, to consider the UDL, you make this as parabolic, right? So moving on to the next, bending moment at B. So bending moment at B, let's find out for the point load first. This is B, so it will be 0.5, 2, that is 2.5, and 3, 4. So total distance from E to B is 4 meters. So minus 2.5 into 4, that is the first one, and the second one is a UDL. So let's solve the UDL also. Minus 1 into 2, that is the load portion, and for the distance, what we'll do, it will be 1.5 plus your 2 by 2. So distance 2 by 2, this distance by 2 remains same, but we'll add 1.5 since we are taking from B. So that's what we have done here at B. Minus 2.5 into 4 minus 1 into 2 into 1.5 plus 2 by 2. This gives your 15 kilonewton per meter. So at the next point, that is at A, what will be the shear force? The total distance is your 5 meters. So minus 2.5 into 5 plus minus 1 into 2 into what will be the distance here? 1 plus 1.5, that is 2.5 plus 2 by 2, and minus 3 into 1. So that's what we have done here. You can see minus 2.5 into 0.5 minus 1 into 2 into 2.5 plus 2 by 2. So minus 3 into 1, which gives you minus 22.5 kilonewton meter. And then we have this your diagram for the bending moment. So only this portion is parabolic and the remaining portion are sloped lines. So this is the shear force and bending moment diagram for this particular question. That will be all for today, but in the next session we'll just cover more. Maybe we'll need 2 to 3 more sessions to cover the most common topics of the simply supported and fixed and your overhanging parts, so that you can solve majority of the questions in competitive exam as well as your course curriculum. So that's all for today. Stay tuned. Bye bye.